So this is going to be an example of building a cloud-free composite. The dates are up at the top. You see it starts in 1999. It's going to take 3 years to build a cloud-free composite over this part of Indonesia, which is depressing. But one of the things I want to point out, this is just to, just to show you how, how the system works in terms of this QA thing, but we are actually keeping all the good looks behind this one image. So some places might have 10, 15 good looks, other places might have 10, or 3. But we retain all of the good data. This is just an image of the one best look as we try to build a cloud-free composite.
That is very cool. We're going to steal this technique from you. Okay. we'll give you a credit.
Go for it.
Okay.
I'll come back to this place because we had a meeting today with Michael Sneed of WWF. This was a national park gazetted and destroyed over the last 10 years in Riau province, but I'll show that later. Anyway, so it took 92 images, more than 20 per path row, 3 years of data, fine. But again, all of that pre-processing, all that cleaning is automated. You hit a button, you go through it. And then you go through, when we work with partner countries, we've tested, we've ported our capability, Indonesia, the 2 Congos, Peru, Colombia, Ecuador. We reduce the data down to these types of stacks of useful images, and then we show how the photo interpretation is done, and the labels of forest, non-forest, or forest loss, not forest loss, to build an algorithm and run it at the national scale. This is the data quality counts, how many good looks there were per pixel, and we keep that as a layer as well. So again, data intensive, useful stuff. This is the cloud-free, first cloud-free Landsat composite built from the Landsat archives. That's pretty neat. And we did this similar thing where we trained on the data, and first deliverable was a 2,000% tree cover map as a reference, and then that's the beginning of the Landsat 7 record, and from that point on we want to map loss and gain. And so we did that. This is what forest cover loss looks like at a global scale. That's what gain looks like, and this is an RGB of the 3. So in this one, green is tree cover, red is loss, blue is gain, magenta is both loss and gain. So at this scale, it's kind of interesting even to look at. So you see big forestry land uses. The whole southeast United States is a tree farm. You can see IKEA in Sweden. The big, forest loss dominated deforestation landscapes of Brazil in the Amazon basin, and then the Chaco from Bolivia and Paraguay. And this is the highest rate of forest loss in the world in the last 12 years in the Chaco. And then Indonesia, Malaysia, that pink tone, they don't take away forests and put in soybean. They take away forests and put in trees. So it looks like it is a forestry land use. So let me just say, why do the global assessment? The FAO is the nominal resource for global information on forest, and they are a member institution, so they have to take definitions and data from individual countries and kind of make them match. Okay, so if you're a Congolese forester and you go down to Namibia, you're going to say there's no forest here, but there's a forestry commission in Namibia, right? Everybody has a different definition of what a tree is, what a forest is, and they submit these data. It's very hard to get them to fit. The biggest loophole in those definitions is land use. North American FAO data is quiet, man. We're just so good at taking care of our forests. There's nothing going on in our forests. There's no area change. Canada gazettes their forest zone, and whether there are trees there or not, forest land use is there, and so they don't report any change in forest because they defined their whole midsection as forest land use. Okay, so they get 0 change out of that. And if they cut the trees down, it'll grow back in 100 years, so don't worry about it. It's coming. Indonesia does the same thing, but they report basically, well, they used to, I don't know what they're reporting now, but it was like 1.8 million hectares per year. But they're doing the same thing Canada's doing. They're cutting natural forest, putting in trees. That's what Canada does. And they totally report different numbers. So the idea of this, this consistently calibrated signal lets you see the biophysical reality, where the trees are, where they've gone away, where they come back, and do apples to apples comparisons